In this video, I'm going to talk about three different types of transform in digital signal processing. One is Fourier transform, one is short-term Fourier transform, and wavelet transform. Fourier transform is very simple. For example, we have this LTI system, LTI signal, and it includes these three different types of sinusoid wave. After we do the Fourier transform in frequency domain, we can see that it reveals that this signal includes this different type of sinusoid wave. But this is for the time invariance signal. If we use Fourier transform to analyze the time variance signal, for example, these two, after we do the Fourier transform in the frequency domain, these two signals is the same, but in time domain it's totally different. It's because Fourier transform can just reveal the overall frequency component of this signal, but the frequency change in time it can't reveal. So that in this case we will use short-term Fourier transform, which is for this time invariance signal. But in the short term, we can say that this is stable. This is time invariance. So we add window to this signal, and we do Fourier transform for the signal in this window, and we will have this 2D figure. This is time domain, and this is frequency domain. And we can see that this signal has three different type of sinusoid wave, and it appear in this time. But the problem of short-term Fourier transform is that the window size. If the window size is big, it means that you will have a bad resolution in time domain, but a good resolution in frequency domain. And if your window size is short, you will have a good resolution in time domain, but bad resolution in frequency domain. So that for high frequency, the small window size is better, and for low frequency, the large window size is better. But you can change window size in short-term Fourier transform because it will create redundancy, and it will make this kind of transform unorthogonal. So that we will choose wavelet transform. Wavelet transform is like, for example, we have a signal like this, and this is time domain. Okay, this is property in time domain. After we do Fourier transform, it reveals its property in frequency domain, but it discuss all the property in time domain. Okay, for wavelet transform, it's like that. It will divide the signal into high frequency part and low frequency part, and it will also downsample your signal every time you divide your original signal. And we can see that in the high frequency part, the sampling rate is very high. It means that when you use the same size of window, you can include more time information. And in the low frequency part, because you downsample it, and it makes so with the same window size, you will include less time information, which kind of makes your window be bigger, so that it solve the problem in short-term Fourier transform very well. And with wavelet transform, we can reveal the property of the property of the signal in time domain and frequency domain very well.